Welcome back. Okay, I can't do it. Welcome back, LeetCode extraordinaires. Welcome back to the hyperbolic coding chamber. Make sure to join the Discord. It is called the hyperbolic coding chamber. We're talking with Discord. We just got a third entire Discord. I mean, we had like 10 million in the first one, around 2 million in the second one. So we're in talks about a third one. Hopefully we can get that up and ready so that more people can join. That being said, it is day 23, I think. I'll double check. It is day 24, actually. Today is July 8th, so almost a month. I plan to make a video about what I learned doing LeetCode every day for 2 weeks. And the thumbnail is going to be me like this. But I'm, hoping to get a lot of views. We'll see. At this point, it's really just about the grind. I mean, having more people in the community is also cool, but I think it's all about the love for the grind. And it's fun to look forward to something to work at. I think we all need that sometimes, something to work at. Something to fix. Shout out a book I read that was pretty dope. It's called Shop Class as Soulcraft. Really good reflections on work. Not to say that life has work, but finding something to work at that ultimately gives us, a look back into ourselves. So that's pretty cool. Besides the point, no more philosophical nonsense. There's nothing philosophical about LeetCode. It is a requirement in the US. So we have to do this. 1 hour and 30 minutes on the clock, but some problems we did yesterday, and some problems we did today. I mean, we did best time to buy and sell stock. I'm gonna keep it a buck. Fried this problem. Very cool problem. I think it's interesting whenever you have to maximize or minimize something. Math.min and math.max usually come in handy pretty well. We did trapping brain water yesterday, but I don't think I was able to solve it in the time frame, and that's really solving it within the time frame is really the litmus test or the barometer I try to use to make sure something's ready to be like space repetitioned. So we're gonna do trapping rainwater again today. I mean, it is what it is. Another book that I took a look at, it's called, I don't know if it was Making Bobby Fischer or a different book, but it's about this guy who was a legendary chess player. And he said that one of the best barometer or litmus test for how good a player will be, or measuring the skill of a grandmaster, is not how many games they've played or how many techniques they've done, but actually how much time they spend looking back over their old games. And so I really like that saying. So I feel like, I mean, even tangentially or anecdotally, it's been true for me. A lot of the thing that's cool with space repetition problem solving as a method of elaborative encoding is that I'll do a problem one way, and then the next time I'll do it slightly different. But just looking at the delta between those two attempts, I don't know, something about it really shows the brain something. But it really cements it further and even gives me like a more malleable model of how that works. So that's pretty cool. That being said, best time to buy and sell stock turned out to be the best time to stop doing that problem, because I was able to do it on the first chance. So we're still going through the grind 75. I mean, I want to do insert interval, but I realized one of the problems that is part of insert interval, which is merge intervals, I actually didn't get to master yet. So I'm actually thinking, I thought maybe if I get a bunch of exposure that would be good, but I'm also thinking that I have a lot of problems lined up behind me. So today I might just do trapping brain water. If we can do that in a reasonable amount of time, we will be pleased. And then from there, we should be able to do another new problem. I want to say it's LRU cache, but honestly, I'm really not feeling confident there about LRU cache. I don't know if I have the brain capabilities today. I'm feeling very deficient in the in the synapse region. I'm feeling very deficient in that spot, even though I got a lot of sleep last night. So hoping to, maybe we'll do trapping brain water. I really don't want to do LRU cache or insert interval. To be honest, I don't want to do any problems today. It's just one of those days where you're fighting back, you're fighting against yourself. But honestly, an hour and a half. We might just do trapping brain water and then just do revisions on problems we've already done in the past. So we'll just keep doing random weighted problems. While I think it's always good to get exposure, and I'm to be honest, looking back, I swap a lot between every video. Every video starts, I'm like, I'm gonna do this. Tomorrow I do the opposite. And that just goes to show day to day, you know, I'm flip-flopping between a lot of it. But what seems to be true or seems to remain true over a long period of time is that we're getting to these problems. At the end of the day, we plan to do all the problems. It is what it is. We cannot be stopped. We will not be stopped. So it is what it is. Yeah, so trapping brain water into random weighted problems. So we usually do the problem we're being blocked on, which is trapping brain water. Then we're going to go into some random weighted problems, and then from there we'll see. If I feel like I can handle a new problem, I'll do it. If I can't handle a new problem, we're just going to keep doing revisions of old problems, because honestly, I think it's better to know a few things very, very well than many things half well. And I think by rushing exposure, since I'm trying to, it's just a bit all over the place. So just gonna jump into it. So 1 hour and 30 minutes on the clock. Don't forget to join the Discord. And yeah, we're gonna jump into it. So let's do it. So we have trapping brain water. I'm going to start the timer. We're going to start a 20-minute timer as usual. So we have function, trap, and we have a height, which is an array of numbers, and we have a number. Given n non-negative integers, which means n positive integers, representing an elevation map where the width of each bar is 1. So we can see that the width of each bar actually is 1. Compute how much water it can trap after raining. So we know that we're only getting positive numbers because of the non-negative integers representing the elevation map. In the above elevation map, black section is represented by an array. Okay, so it looks like the array is actually being represented by these black dots, these black boxes with 1. We have to compute how much water it can trap after raining. So what's important to know is that this array only hints at the black cubes, and it's how much water it can trap after raining. So we know that we can trap water when our block is at least closed or met by a block of similar or greater height. So what I mean by that is that we have a block here 1, and we find the next index 2 here, which is greater than or equal to 1, and we know that we can trap the minimum height of the 2 minus the block value at that value. So to calculate this, we would say find 1 where our block starts, then at 2 we know that we have an end of a run, and then for this run we can calculate the water bucket. We can do that by taking the minimum of the 2 heights, which would be 1. If we take 1 to calculate the bucket depth, or the water we can trap, we'll just do the height, which is minimum height of the both, which is 1, minus the value at that indices. So it's 1 minus 1 is 0, 1 minus 0 is 1. So we have 1 block of water, and 1 minus 2 is not positive, so we want to skip that as output. So we know we want to skip bucket calculations that aren't positive. So one of the premises required from this problem, again, for the way that we're going to solve it, is that we know that we can find the next end of the run when our left side of the block is lower than our right side of the block. So what I mean by that is if we check if we have two potential blocks, right? One, let's just say we start here, right? We have two potential ends, right? We know that 2 here can be a potential end because 1, we're looking for a block that's either greater than or equal to our height so far, which would be 1. But if we start at a block that's higher, right, it's actually hard to know when to stop, right? Do we stop at 2 here or do we stop at this one here? So that's confusing. So I would say, since we know that we can solve it when we're going from low to high, I would say the best way to do it would be to iterate from both sides while always choosing the one that allows us to go from low to high. So if we iterate from both sides of the array, right, we'd skip this indice here by some method in the code, and we simply choose the one where their values are smaller. In this case, they're the same, so we default to the right-hand side just because of the else case, right? And so we try to find a block that is greater than or equal to 1 to stop. We'd find the next block over. Since we'd find that block, right, we wouldn't be able to calculate anything, so we'd go to the next iteration, or we'd have this block and this block, right? The smallest of the two is going to be this one, and now we just have to find the next cube going forward, right, that is greater than or equal to the minimum height of both of them, which would be 1, which would be this cube, and then we can calculate the rainwater. So I think we can visualize this, right, with pseudocode. So we'd have water, right, we want to iterate over height. We're iterating over this array, but from both sides, right? So iterate from both sides towards center. To do that, we'd have a left and a right, right? And we said we want to make certain, right, that when we do go into the bucket calculation phase, that we're going from low to high, not high to low. To do that, we'll have to choose the smallest of the two, right? So I have to check if height sub left less than height sub right, right? Then that means left is lower, right? Otherwise, it means that right is lower. In this case, where we're starting with 0 and 1, right? 0 would start us, right? So we'd go into here, and the first thing we want to do, right, is we don't want to start at 0 for our calculation because we're already at 0, and where we're at is excluded from the calculation. So basically, we want to keep going forward, right, until we find a cube that is greater than or equal to 0, right? So while height sub left is greater than or equal to height, so we'll see, right, that if we do greater than or equal to height sub left, we end up running into an issue. That's when we'd like to stop, right? So we want to reverse it to keep going. So while height sub left is less than height sub left, but we know that this will never run because the value will always be the same. So we're going to need to store this value, right, this original starting point, right? So create current equals left. From here we'll have while height sub left, right, is less than height sub current. And by this method, we're almost there, right? Because we have two different methods, right, to iterate forward. The problem being we'd still have the same problem where they're starting at the same value. So what we want to do is push it over once just to force it a little bit into iterating. So do left plus equal 1, right? And so now left will be here, right? And we'll say while height sub left, which would be 1, is less than height sub current. It's not, right? So we're not going to do anything, right? But if we just ignore this first case and go forward just so we can continue writing this code, because this is more of a process-driven approach, we'd have 1 here, right? So our current would equal index 1, and we would say left plus equals 1, so left would now be at index 2. We'd say, well, height sub left, which is 0, is less than height sub current, which is 1, right? We want to calculate water, right? So how do we calculate water? We would say water plus equal. You have to remember our premise from earlier, right? We don't want to add anything to water that's not positive. So how do we calculate water? Well, we said it would be height sub current, right, minus height. So actually it might be easier if we just say potential water equals height sub current minus height sub left, right? And if potential water is greater than 0, we'll add it, otherwise we won't, right? So we get 1 minus 0, which would be 1, which would be that one bucket we're looking for, and we want to move left forward as usual, right, for a progress step. We go to the next iteration, right? We check if height sub left, which would now be 2, is 2 less than 1. It is not, so we'd stop and we'd have 1 cube of water in the bucket. So that is pretty cool. So now we need a version of this, but for the right-hand side, right? And like we said, we always want to be going from low to high, right? So if we imagine this iteration, right, let's just say left is at this point right here, which would be 3, right? So this would be an else case, right? And let's just say we're at 2 here, right? So what would we like to do? We know that height sub right is left than height sub left, right? We want to do very similar code, right? So we'll paste this here. We'll say current equal left. We'll keep a local pointer of current, right? We want to go left. So it's a little confusing. We're at the right hand side of the array. We want to go left. To do that, we're going to do minus equals 1. So write minus equals 1, right? And let's just see if we want to keep going forward while height sub right, which would now be this index right here, 1, is it less than current, which was 2? Yes. So that actually works in our favor as well. And potential water would be height sub current, which is 2 minus height sub left, which would actually be 1. So we'd add 1 cube of water to our water since it's positive, and we do a progress step, which would be right minus equal 1, and we would return water at the end. So that is pretty interesting. And we also important to note that these right minus equal 1s and left plus equal 1s beforehand is just to force progress, right? Because we actually start at the node we're at, right? If we omit this line, we'd start the node we're at, and this while loop would never run. So we want to know that whenever we at least get to a spot where one side is smaller than the right side, we want to move forward at least once, right? So that's how we force progress, right? So now let's iterate it. I mean, it's implemented. We'll say water equals 0, left equals 0, right? Right, when we're iterating from 2 sides of the array, it's always going to be the length of the array minus 1, which would be the last element. Let's iterate from both sides of the array, right? Excluding, right, when they can be the same. It'll be while left is less than right. I'm going to do while height sub left, right, is less than height sub right. Then we want to get into this code, right? And it'd actually be easier if I just uncomment this line, add a bracket, then add another bracket. Right, and we said let current, actually for the sake of not redeclaring values, we'll just say, we can just uncomment this line actually and do current equals left. Uncomment this one, left plus equals 1. And we can actually just reuse this one while height sub left is less than height sub current, right? You want it to say potential water equals height sub current minus height sub left, right? We'll delete that and we can just uncomment this one, right? We only want to add if water is positive, right? And we'll keep our progress step. So add semicolons to these, duplicate this, and it should be very similar code, but we'll keep it just to double check. Current becomes right. That slight progress step we do in the beginning becomes a decrement. Right, left becomes right, and this subtraction becomes height minus right. And our small progress step becomes right and decrement. So we can delete all these lines. And we'll test it really, really fast. I'll delete the pseudocode. To test it really quickly, we'll do 4, 2, 0, 3, 2, 5. So left starts at 0, right starts at 0, 1, 2, 3, 4, 5. Starts at 5. 0 is less than 5. Is height sub 0 less than height sub right? Yes. So we know that at the worst case, we'll meet our right-hand side if, you know, there's nothing in between. So we'd have 4 going to 5, right? Current is going to equal left, which is our current index, which is going to be 0. Left plus equals 1. We'll do a small progress step forward since we already saved the value left. So we're actually going to be at 2 now. So while height sub left is less than height sub current, so height sub left, which is actually 2, is less than 4, which is perfect. So we'll calculate the water. It's going to be 4 minus 2, because current is 4 and left is 2. 4 minus 2 is 2, which is positive, so water equals 2 so far. Then we're going to go forward again, right? Is height sub left, which is now 0, less than 4? It is. 4 minus 0 is 4, so water is now 6. Going to go forward again. We're going to say, is 3 less than 4? It is. So 4 minus 3 is going to give us 1, so water is now 7. We're going to go forward again and up to 2, where is 2 less than 4? It is, so 4 minus 2 is going to be 2. Water is now going to be 9. So it looks good with left plus 1 going to 5. And so we should be at index 5 now. Is 5 less than 4? Nope. We'd come out, we would say, is 5 less than 5? Nope, we'd return water. So for that case, it does look good. Let's run it. This looks good. So we have function trap, which looks good. And I feel good about this solution. We have 4 minutes remaining. And I'm just gonna, personally I don't really feel like reading the solution, to be honest, because I don't get how they're solving it. But I read it anyway in hopes that maybe a droplet will fall into my brain as to how they're doing it. We have 4 minutes left. We have nothing to lose by doing this. Time complexity of the solution would be worst case linear time with constant space. In brute force, we iterate over the left, right parts again and again just to find the highest bar size up to that index. Do as directed in question. For each element in the array, we find the maximum level of water it can trap after the rain, which is equal to the minimum of the maximum height of bars on both sides minus its own height. So for each element in the array, we find the maximum level of water it can trap after the rain, which is equal to the minimum, which is equal to the minimum of maximum height on bars on both sides minus its own height. So for each element in the array, start at index 1, find the maximum level of water it can trap after the rain, equal to the minimum of the maximum height of bars on both sides. Minimum of the maximum? Wouldn't that just be the minimum? On both sides minus its own height. So ands equals 0. Iterate the array from left to right. So we're doing initialize left max equals 0. Okay, left max does equal 0, and right max equals 0. Iterate from the current element to the beginning of the array. Okay, left max so far would be 1. Iterate from the current element to the end of the array, taking the right max. So the left max is 1 and the right max is 3. So what do they do with that? And add the minimum of left max of right max minus height I to ends. So it's either 1 or 3. It would be 1 minus heights of I, which would be 0. I see what they're saying. Then we go to the next one. We'd find the highest one we can find, which is 1. And we'd find the highest one we can find again, which would be 3. And then we'd subtract the minimum of that, minus 1, which would be 1. For this one, we find the highest on the left side, which would be 2 itself, and the highest on the right side, which would be 3. And then what do? Add the min of left max or right max. So this would be 2 minus 2 would be 0. They go to the next iteration, we find the minimum, which would be 2, and then 3, and then we do the minimum of both, which would be 2 minus 1, which would be 1. I see what they're doing here. I see what they're doing. I see what they are doing. Interesting. It's hard to feel the intuition that they use to get that answer, but nonetheless, we will take it as a W for this answer, and we will do a random weighted problem starting the 20-minute timer again. We're going to do add two numbers. We have function, add two numbers. We have a list node, another list node, and we're returning the list node. So you have 3 linked lists. You are given 2 non-empty linked lists. So you can see 2 non-empty linked lists representing 2 non-negative integers. Okay, the digits are stored in reverse order. So we have 2, 4, 3, which actually represents positive 3, 4, 2, and 5, 6, 4, which represents positive 4, 6, 5. Each of their node contains a single digit. Add the 2 numbers and return the sum as a linked list. So you have 2, 4, 3, 3, 4, 2 plus 4, 6, 5 equals 8, 0, 7. And the output is returned in reverse. We assume the 2 numbers do not contain any leading 0 except the number 0 itself. So we see confirmation of the reversal here. And they even show us an edge case. We're adding all these 9s together actually produces an extra element in the linked list. The number of nodes in linked list is up to 100, so we have to do this with elementary addition, linked list style. Manual style, 1 by 1 through. And it's guaranteed that the list represents a number that does not have leading zeros. Cool, cool, cool. So I would say, so we could just do this linked list style, right? And simply add through. So we basically do this by hand. So 2 plus 5 produces 7. 4 plus 6 produces 0. 3 plus 4 does not produce 8 because 4 plus 6 produces 10 with a carry of 1, which would be 3 plus 4 plus 1. So we know by default we're going to be iterating while L1, L2, or carry exists. We know that because their extra edge case here shows that even when there's values remaining, we can see that this propagation of this one carrying produces an extra node at the end. We can recreate this by just doing 999 plus 99, or it might even just be easier if we just do 999 plus 1 plus 11, which actually doesn't produce the value. Let's just say 999 plus 999 plus 19. So we do 1 plus 9, which gives us 10, right? And we're seeing that whenever we have 10, right, the value that gets placed is going to be the sum modulus 10. So that would be 0 here. And the value that gets carried is always actually the sum divided by 10. So we're going to have 1 up here. So we'll have 19. 9 plus 9 is 18 plus 1 is 19, right? And like we said, the value that gets placed on here would be 19 mod 10, which would be 9. And the value that gets carried is always 9. It's going to be the sum divided by 10, right? So we'd have a 1 here. Right? 1 plus 9 actually gives us 10, right? And 10 mod 10 would be 0, right? And so we'd actually, that's why we have or carry, because we'll have one more number left over for which we'll need this extra node, and that should give us the value 1090. So 999 plus 19 does not equal 1090. So 1 plus 9 equals 10. We carry the 1, that's 9 plus 9 is 18, which gives us 19. We drop the 9 down here, carry the 1, which gives us 10. Carry the 1, which gives us an extra 1. If you reverse that, you get 1090. 999 plus 19 gives us like 118 or something like that. Okay, let me restart. 999 plus 19. This gives us 10. Right, we put the 1 up here. 9 plus 9 is 18 plus 9 gives us 9. 18 plus 1 gives us 19. Now that we have 19, we carry the 1 over to this 9, which gives us 10. And we get, which gives us 1090. I guess what I'm doing, I'm trolling. So since we're adding the numbers in reverse, right? 190 actually, 19 can't be a number you add since the numbers are in reverse. So for example, if I give us 133, in reverse this number is actually 331. For the same thing, if I give us 13, this number in reverse is actually 310. So 999 plus 190, does it give us 1090? Let's check. 999, 990, oh no, it's 999 plus 190 gives us 1189. So I think we're trolling in some respect here. So 999 plus 190, we'll have 9 here, right? We carry the 1. 9 plus 9 is 18 plus 9 gives, 9 plus 9 is 18. If you add 1 to it, you get 19. 19 mod 10 gives you 9 remainder. 19. So we carry another one, which would give us 10. We get 1090. Why is node giving me 190? Either I'm wrong or node is wrong. So I'm pretty sure node is wrong. No, I'm joking. So let's try 998 plus 190, or 1000 plus 190. Yeah, something is very strange here. Let's just say the numbers you want to add together are 990 and 190. In reverse, that would be 99 and 091. So it would actually be like this. So if we were actually adding 190 and if we were actually adding 999 and 190, it would actually be like this. That's why we keep getting the wrong answer. We're not respecting the exact rules. The numbers, both of them are in reverse. So 9 plus 9 is 18, right? Plus 9 plus 9 is 18, so we put the 8 here. We carry the 1, we actually get 11. 11 mod 10 is 1. We carry a 1, it's going to give us 11, 1, 1, 8, 9. So 990. 999. I'll delete all this extra nonsense. 999 plus 190. So 999 plus 190 equals 1189. Okay, so we are on the right track. So that makes sense. So we can follow our original idea. We're just going to do elementary addition. We know that we need to worry about while our carry exists. And since we're actually going to be creating a linked list, there's a special method you can use that simplifies the return. Because I know in the last problem we did create then go to it. In this problem we want to do create with value then go next. If that's the case, and that means where we start we want to be a dummy node. So we have an output, which is going to be a new list node. I guess we'll keep a dummy head. So this is so we can return dummy head.next. And then we're going to have temp I'm going to have temp, which is equal to dummy head. Then I think we can do dummy head.next equals new list node and then go to it. So iterating while L1 or L2 or carry. So first we have to create the sum, right, with nullish for any of them not existing, right? Sum all three with nullish, right? So we can get a sum even when we run out of elements to add for a number. If the sum exists, we have to create a node for it. So the sum, so value is the value that's actually going to be placed in the node, and that's always going to be sum mod 10, right? Carry is always going to be equal to the floor of sum divided by 10, right? Like we spoke about earlier. Now we have the three values we need. We just need to basically propagate this into a tertiary linked list that we can return. So we'll say temp.next equals new list node. So this is a mix of pseudocode and actual code. It'll be value, and then we can say temp equals temp dot next. At the same time, right, we're going to have to increment all of these if they exist. In JavaScript, we can do nullish coalescing, but in other languages, we'd have to use probably some if statement or something to protect. In that case, we would do L1 equals L1 dot next, and we probably okay if we butcher our references to L1 and L2. And actually, maybe it's not, so we'll create T1 equals L1, T2 equals L2, because we don't want to butcher our references. So we probably shouldn't butcher our references to the linked list they pass into the function. To prevent that, we'll do T1 equals T1 dot next, but only if it exists. T2 equals T2 dot next, only if it exists. I'll create an extra bracket, and then I'll create our point like we did earlier. So while T1 or T2 or carry, yeah, or we can just do or carry like that. We'll say con or let carry equals 0. So even when we have an extra node at the end, for our one value, we should be good because we created temp.next equals new list node and temp.next. Then we can return dummy head dot next. So I think we can just implement this. Sum equals T1 dot val if it exists, otherwise nullishly coalesce to 0. T2 dot val if it exists, or nullish coalesce to 0, and then plus carry. We'll say const value equals sum mod 10. We'll say carry equals math.floor of sum divided by 10. And so just to test this, simple input, we do 2, 4, 3, and 5, 6, 4. So T1 equals L1, T2 equals L2, dummy head, temp equals dummy head, carry equals 0. T1 and T2 both have values, so we're summing all three with nullish. It's going to be 2 plus 5 plus 0 equals 7. Our sum is going to be 7 mod 10, which is 7. Our value is going to be sum mod 10, which is going to be 7. Right, and so list node gets the value of 7, math.floor gets the value, carry gets the value of 7 divided by 10. 7 divided by 10 is 0, floor is 0. And then we create a list node of 7 and go to it. Then we do next on both. 4 plus 6 gives us a sum here of 10. Value is going to be 10 mod 10, which is 0, so the list node gets a value of 0, which is perfect. Carry gets a value of 10 divided by 10, which is going to be 1. Floor is 1. So we have a carry of 1, create the node 0, move to it, and we go next for both. Now we have 3 plus 4 plus carry, which is going to be 8. Sum gets the value of 8 mod 10, which is 8. So we create a new node with 8. Then we take a carry, which is going to be 8 divided by 10, which is going to be like 0.8. Floor is 0. And we should be done. Just for the sake of testing, let's just say it was 3 plus 6 with a carry of 1. In that case, we'd have 0 here for the node, and then both T1 and T2 would be null because the next would be null. The sum would be 0 plus 0 plus 1. Sum would be, our value would be 1 mod 10, which would be 1, so we create a new list node with 1 instead of the temp.next, which would be perfect, and then carry would be equal to 1 divided by 10, which would be 0. So let's try this. both T1 and T2s are constant, as well as temp. So that looks good. So that looks good. The runtime of this is going to be L1 plus L2 time with a space complexity of constant space. If we ignore the output of the function, if we include the output, then I guess the number of operations it wouldn't be m plus n operations because some of them are included. It would be the max of m or n. The space complexity was max of m and n plus 1. I see what they're getting at. That does make sense. So that looks good. So we'll start a new timer. Let's do another one. We'll do toSum. toSum makes sense. So we have function toSum, we have nums, which is an array of numbers, and we have target, which is a number as input, so an array of numbers and a number, and the output is an array of numbers. Given an array of integers nums and an integer target, so we're given an array of integers and an integer target, return indices of the two numbers such that they add up to target. We may assume that each input would have exactly one solution. We may not use the same element twice. You can return the answer in any order. So the two indices that add up to 9 are 0 and 1, which makes sense. Two indices that add up to 6 are 1 and 2, makes sense. Two indices that add up to 6 are 0 and 1, and since we can always assume there's at least one solution, we don't have to worry about returning -1. So nums, there's always at least two elements in nums because they have to add up to the target. And only one valid answer exists. So we can actually do an answer that is linear time with linear space. And the intuition for that is that since two numbers have to sum up to a number, if we keep track of all the numbers we've seen so far, we can check for a number's complement that we could subtract from the target to find to see if that number exists in the map. What we mean by that is if we have 2, 7, 11, and 15 in the array and our target is 9, if we're at 2, we do 9 minus 2 gives us 7. We just have to check if in the map so we could have used a set, right? So if we check if and the reason we can't use a set is if we do 2, if we check if 9 minus 2 is in the set, no, right? So we add 2 to the set, then we go to 7. If we check if 9 minus 7, which is 2, is in the set, well, it is in the set, so we know that 2 and 7 add up. The problem is we have to return the indices such that they add up to the target. If we use a set, we'll know that two numbers sum up to a target, but not from what indices they do. So the way we solve that is by doing a map of number to number. And so the map actually stores a key value pair where the key is the number and the value is actually the index. So we can do this in one pass by trading space for time with linear space and constant, and linear space and linear time. Do that, we can do I equals 0, I is less than nums dot length, I plus plus. And maybe there's a simpler way to get the information we need. We just need the number and the indice. Then we can do const idx and num of nums dot entries, right? And we'll say if map dot has target minus num, right? Then that's the best case, right? Since we can return the indices in any order, we can just return idx and map.get target minus num. Which would be the value, which would be the index, right? If the complement doesn't exist, right, we'll just add it, right? And we have to also note that this doesn't exactly work if we don't have unique solutions, so there can't be more than one number in an array, more than two numbers in an array, right? There can't be more than two numbers that sum up to a value. So if we had 3, 3, and 3, right, we need the answers to be unique such that we can return 0 and 1, or 1 and 2, or 2 and 1, or 2 and 1. So we would set the number, right, to the index. And since there's at least one answer, we should be able to solve it with just this. So we'll check. So do 2, 7, 11, 15 with target equals 9. The map is set to empty. So index and number. Does the map have 9 minus 2? Nope. So we set the map key to 2 and the index equal to 0. Then we go to 7. We check, does the map have 9 minus 7, which is 2? Well, it should, right? So return index 0, index 1 where we're currently at, and map.get the complement, which would be target minus num, which would be 2, which would be mapped to its index. So that looks good. So that's the one pass hash. So we're trading space for time. And you can do this in n log n time with constant space, but actually no, without no, it would still be linear time because you need an array of the numbers that you would have to sort. It depends on if you can pretty much mangle the input into the array, and if you could, it would technically be constant space, and you could sort the array in place. But that looks good. And then we'll go to the next one. You have merge intervals, which we haven't done in a very long time. Let me see. Yeah, this one should have been in there sooner, but failed to do so. So this one's probably going to be trouble. We have function merge. We have the function merge. So we have the function merge, which is a matrix of numbers. We're returning a matrix of numbers. Given an array of intervals, where interval sub I is equal to start sub I, end sub I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So first part makes sense, the second part doesn't. So we have intervals. So, all right, start sub I and end sub I gives us the start end of the interval. We have 1, 3, 2, 6, 8, 10, 15, 18. And they're going to merge all the intervals. So 1 and 3 overlap between 2 and 6. So it turns out we can merge these to be 1 to 6. 1 and 6 doesn't overlap with 8 to 10. Neither does 15, 18, so we return this. Okay. We have intervals 1, 4. 4 does overlap with 4, 5, so we can return just that one merged interval. Intervals length can be up to 10 to the 4 intervals, but the columns in every tuple, we know that the array is always an array of tuples. There's no broken input. Start and end can be quite large. So intuition, given these examples, right, It doesn't say that we can assume that the array is sorted. So what we can do is sort the array based off of interval sub 0, should be the start. So that would allow us to use these examples in our process-driven algorithm. So from here, do 1, 3, 2, 6, 8, 10, 15, 18. So from here, how do we know if something overlaps? Well, if, let's just say, given 1, 3, and 2, 6, how do we know that 2, 6 overlaps with 1, 3? Well, if the start of 2, 6, which is 2, is less than or equal to the end of 3, then we can merge them. So if cur 0 less than or equal to cur I minus 1, merge. So in this case, I'm thinking if we iterate over intervals, since it's now sorted, we can do if cur sub I is less than or equal to cur sub I minus 1, but we know that intervals can have at least one interval in it, so we need a way of getting started. If that's the case, we could probably start our output with the first interval's value in it. That would be problematic in the case where none of them are mergeable. Or if we start it like that, let's see. Then we could check if just the last element on the output is mergeable. So our output would start with 1, 4. Then we could check if cur sub I is less than or equal to output end, right? And we mean the start. Let's just be very specific about that. Then we could just merge them by updating output end. So merge by updating output end. So that actually works for 1, 5. Does it work for 1, 3, and 2, 6? If we have 1, 3, we start with 1, 3 in the array. Well, if there's only one interval in the array, which there can be, we'd always return that anyway. So it ends up working. Now if there's at least 2, we want to skip the first iteration because that element's already in it. We don't even have to skip it because if cur sub I, if they're the same, is less than or equal to, so we'd merge by updating. So if we merge by updating, it's actually in place, so it actually doesn't matter. So starting with output looks like it can work. So let's actually just try and implement it. So if we do const interval of intervals and merge by updating, when do we push when they when they don't match? So if we do 1, 3 would be in our start, 1, 3 would merge by updating the output, so we'd update it to be the same. Wait, would 1 be less than or equal to 3? So yeah, we update it by making it the same. Then we go to 2, 6. Well, cur sub I sub 2 actually is less than 3, so we merge by updating the end, so that range would become 1, 6. Then we'd go to 8, 10. Well, if the does 8 start, is 8 less than the end of the interval? no, since it's not, we probably just want to push 8, 10 onto the stack. Else, all right, so we can actually just push the output, push the interval onto the stack, and since we're always updating the last one, it allows us to work pretty well with it. So instead of writing pseudocode specifically for these, I'm just going to update them. So we have cur, not cur, the interval, right? And it's if output sub end, output sub start. It'd be interval subs. So interval is where we currently are, and we want to merge them if the current value, the current start, which would be interval sub 0, is less than or equal to the last element in the output. Could be output dot length minus 1 sub 0. So output, the last element output would be 1, 3. Get the, nope, we don't want it to be the start, we want it to be the end. So if interval start is less than the interval's end, then they overlap. So we want to merge by overlapping, merge by updating. So we just say output dot length minus 1 sub the end, right, would get the value which would be 1, 3. We're currently at 2, 6. It would get the value of interval sub 1. So that looks good in my head. I can return output. Sheesh. So that looks good. And we're failing on a particular input, 1, 4, and 0, 4. Oh my god, we forgot to sort the array based off intervals. So we just change this to intvs. And we'll change this to intvs. And we'll say intvs equals intervals dot sort AB, and we'll do A sub 0 minus B sub 0. We need one more dot to spread it. Okay, so now so it's sorted. What's first in the array is going to be 1, 4, what's first in the array is going to be 1, 4, right? We're going to update it in place for 1, 4, and then we're going to go to 2, 3. We're going to check if 2's start is less than 4. It is. We want to merge them, so we actually want to take the max. I'll take the max, it seems, of the interval, right, of the current interval in by the method in which they overlap, or the current value already on it. And so I think in this way we should be good. So that looks good. This looks like a linear time solution. In linear time solution with what kind of, no, it's not a linear time solution. It would be an m by n solution where m is the number of rows or I guess since we know there's always two columns, it would be n, where n is the number of tuples, times two operations, where we drop the constant. But it's not really, yeah, it would be 2, so we drop. So we really can just say it's linear time, where n is the number of tuples that actually exist. Space, I guess, would technically be linear space, where n is the number of tuples, because we're creating another variable in which we sort the values So they're doing a whole bunch of graph stuff here. I don't think that's necessary. So if we sort the intervals by the start value, then each set of intervals that can be merged will appear as a contiguous run in the sorted list. First, we sort the list as described. Then we insert the first interval into our merged list. Then we insert the first interval into our merged list. And continue considering each interval in turn as follows. The current interval begins after the previous interval ends, which makes sense, and they do not overlap. Oh, right. We can append the current interval to merge, otherwise they do overlap. So we did the opposite of that. If they do overlap, we do work, and if they don't overlap, we push the interval. We can merge them by updating the end of the previous interval if it is less than the end of the current interval. Simple proof by contradiction, so that its algorithm always provides the correct answer. We're not going to read all that. So they sort it with a lambda function for intervals. I think it simplifies it just to put the interval already in the array, since they guarantee us input. And they're saying the time complexity, oh, it wouldn't be linear time, right? Because we'd be bounded by the time of the search. The search would take the longest here because it'd be n log n. Ah, they got me there. The search would indeed be bounded. That's right, because the time and space complexity is always the worst case. Makes sense. Makes sense. So I think we can do best time to buy and sell stock. So we have a function max price. We have an array of numbers. We have to return a number. We're given an array prices where prices sub I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock, choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So the array of prices, the price of a given stock on the ith day. To maximize your profit by choosing a single day to buy, choosing a different day in the future to sell. To maximize this, we have to buy low and sell high. So the lowest you can buy is 1, and the highest you can sell for is 6. And the profit would be the price of the sale minus the buy-in price. Let's buy on day 2 and sell on day 5. There's no day you can buy in here. There's no day you can buy in here. So the profit, and buy make a profit, so the profit is 0. So if we have to maximize or minimize, we're usually thinking math.min and math.max in some capacity here. So one way we could do this is just keep in mind always the lowest price we could have bought it for. So if we start with 7, right, and then we'll do 7 to take our profit, we'll always do the current day, right, minus the lowest buy-in so far. So if we do 7 minus 7, that would be 0, right? And then we'll try to find our newest max profit. First, we have to find our lowest buy-in. So that would be the math.min of 7, right, which is the lowest we've seen so far, and 1. That's going to be 1. And so the maximum profit we can make is going to be the current day minus the buy-in, which would be 0. So if we go to 5 on the next iteration, the math.min of 1 and 5 is going to be 1. So if we sell today, we could make 4, because we could do the max of 5 minus our lowest buy-in, which would be 4. 3 would not be good profit, but once we get to 6, our lowest buy-in so far is still 1. We could do the max of profit, which would be 6 minus 1 equals 5. So from here, we know we had iterate over max profit, minimize buy-in, maximize profit. To simplify this, we could do let profit equal 0. But we don't always get 0. We'll let lowest buy-in equals 0 before num for const price of prices. To minimize buy-in, we would always take the lowest buy-in is equal to the math.min of price, or lowest buy-in or price, like we said, and profit would always be equal to the maximize profit, or current price minus our lowest buy-in, then we can return profit. So we run it with this in mind. Our lowest buy-in is 0 and our profit is 0. Our lowest buy-in would be 0 and 7, so it would be 0. Then we'd go to maximize profit, right? We'd have to do profit maximize of 0 or 7 minus 0, which is 0. Then we go to 1. Lowest buy-in would be either 0, right? So we can't start with 0 because 0 always wins as the lowest buy-in. To do that, we can just set positive infinity as our lowest buy-in. That way we actually always get the lowest buy-in. But always be set to 0. I don't think this problem took 20 minutes. I think I forgot to reset it. So we'd have math.max of profit, and profit would be 0 at this point. We'd have a price minus lowest buy-in. Lowest buy-in so far would have been 5. Our lowest buy-in so far would have been 7. So it's either 7 or 0 minus 7. So that's no good. Then we go to 1. Our lowest buy-in so far would either be 1 or 7. So we take 1. Our maximum profits for I would either be 0 or price, which is 1, minus lowest buy-in, which is 1, which is 0. Then we go to 5. Our lowest buy-in would be 1 still, because 1 is less than 5. Then we do either 0 profit or 5 minus 1, which is 4 for profit. Maximize that would be 4. And we'd keep going. Our lowest buy-in would still be 1. So I think this does work. So this would be linear time with constant space. I think my server just crashed. I have to fix that later. In that case, we might as well just try insert interval as a start. So we are given a function insert. We have inputs intervals a matrix of numbers, and we have new interval, which is probably a new interval. We have to return a matrix as well. You're given an array. There's only 20 minutes left, so we'll just use a timer. You're given an array of non-overlapping intervals, where intervals sub I is equal to start sub I, comma end sub I, represent the start and end of the ith interval. Intervals is stored in ascending order by start I. So it's pre-sorted for us, unlike in merge intervals. That represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start I. Intervals does not have any overlapping intervals. So this kind of reminds me of merge intervals. So we have an interval 1, 3, and 6. Now we have to insert 2, 5. 2, 5 looks like it can be merged into 1, 3 and 2, 1, 5 with 6, 9. So you have 1, 2, 3, 5, 6, 7, 8, 10. And maybe it can't cause a I was thinking it might be able to cause a cascading of interval fusions. The new interval is 4, 8. So it looks like it'll go here. Oh, it can. So it'd go to 3, 10. The new interval 4, 8 overlaps with 3, 5, 6, 7, and 8, 10. Okay, so it looks like what we can do is just find slot to insert interval, run merge intervals algo. So how do we find the slot to insert the interval? Well, since it's already sorted, we can do it in worst case linear time, whereas resorting the list would take n log n time. To do so, we could just do for I equals 0, I is less than intervals length, and we know that intervals always has 2 intervals in it. Start and end can be up to 0 and 10 to the 5, and start I is always less than end I, which is good. Intervals are sorted by start I in ascending order. New interval length is always 2. Start is always less than end, so that's pretty good. Do I plus plus. So we want to insert the interval. When do we want to do that? If we iterate over the intervals, we can just check if while new interval sub I is less than interval sub I sub 0. So it might be easier with a while loop actually. Let idx equals 0. We'll just say while new interval sub 0 is less than intervals sub idx sub 0. Just do idx plus equals 1. So here we start at 0 and we say is 4 less than 1, 4 or equal to. Is 4 less than 1? No. Is 3 less than 1? No. Is 4 less than 1? No. Is 4 less than 3? No. Is 4 less than 6? Yes. So we'd stop there at 1, at 0, then we go to 1, right? And we check if 4 is less than 3, then we go to 2. Is 4 less than 6? Yes, it is. then we go to 3, 0, 1, 2, 0, 1, 2, 3. It's not, so we'd want to insert it at this index. So new index, insert it at this index. We probably don't want to mangle our input. And we'll have inserted after. And we'll use splice at this index. We won't delete anything, and we'll insert new interval. And then we can just console.log inserted just to make sure that, and we'll just return inserted even though it's not the right answer, but it's just to check output. Splice doesn't return anything, so it's better to just do it like this. So the new interval is 2, 5. New interval sub 0, which is 2, is less than or equal to interval sub idx of 0. So 2 is not less than 1. Somehow it was inserted at this index. Oh, I used 0. So it's idx. No, wait, we're deleting, not deleting any elements, but it's going in at idx. 2 less than 1. It's 2 less than 1. It is not. So we're stopping there, which makes sense actually. I think this means we just need to do it to the next index. So that looks good. I'm going to change the input just to double check something. If I do add 2, 5 already into it and just change this to 3, 5, I want to make sure it comes out in the correct location. We'll change this to 7, and we'll change this to 6, 7, and we'll change this to 8, 9. So this should go after. So this is not working as intended. So is 6. I think what I'm going for is that 6 should be if while 6 is greater than or equal to the number, then add it. Do while 6 is less than. So I think this is a coincidence that this works, because we're not actually doing anything yet. But let me make sure it works when things are small. So if I do 2, 3, 4, 3, 2, 3, and I try to add 0, 1, 0, 1 should go in the front. Okay, so that does work. While new interval is greater than or equal to interval. Then we just want to merge the intervals. So from here to merge them, we'll just do const merged, right? And we're just going to start it with inserted sub 0. Right, and from here we can just check for const interval of merged if, and we'll just do last merged equals merged, so merged dot length minus 1. We know this will always, intervals dot length isn't always equal to 0, so we only want this to run if merged. We only want this second bit if inserted dot length is greater than 1. So you want to run this code. Otherwise, we can just return inserted. Or actually, it's easier if we just do it in the blocking style. We'll just say if inserted dot length equals 1, return inserted. That way we can ignore the if. Log. So remove that. So we're merging that one interval in, and then we have interval to merge, so we just want to merge the intervals. So the merge is going to get the value of the first, since it's already sorted in the array. Then from here, we'll just update it on the last one if they're overlapping, and if not, we'll just push it. So we're actually going to have merge is what we're going to use, and we're actually going to iterate over the inserted array. That's going to be actually last merge is going to get the last. Okay, so from here, all we have to check is if the current intervals start is less than or equal to the last merged end, and if it's so, we can just update last merged end to the math.max of interval sub 1 or last merge sub 1. Otherwise, we can just push the interval if they don't overlap. So what does that look like for this one? We have 1, 3, 6, 9. Our new interval is 2, 5. So we know this. So while the new interval, which is 2, 5, is greater than or equal to the start of the current interval 1, 5, we're going to idx plus 0. So we're going to go forward once. So is 2 greater than 1? It is. Is 2 greater than 6? No. So we're going to insert. We're going to create inserted, right? Which is just going to be the intervals with the inserted new interval, right? So it's inserted lengths equal to 1. No, it's equal to 3 actually. So it'd be 1, 3, 2, 5, 6, 9. From here, merge is going to start with 1, 3, right? And it's going to remerge over its current index. We can see that because last merge is going to be 1, 3. We're going to check if 3 is greater than, 3 is less than or equal. Well, if you started the current interval, which is 1, is less than or equal to the end of my own interval, which is 3, which is always going to be true. So last merged sub 1, which is going to be 3, is going to get the max of 3 or 3, which is going to be 3, so it's going to merge over itself. Then we're going to go to 2, 5. We're going to check if interval sub 0, which is going to be 2, is less than or equal to 3. It is less than or equal to 3, so we're going to update 1, 3 to be the max of 3 or 5, so it's going to get the value of 5. Then we're going to be at our third interval, which is 6, 9, and we're going to check if 6 is less than or equal to 5, and if it is, we're going to merge, and then we're not going to. So this looks good. Let's see if it runs. Right, and we're supposed to check. Let's see if new interval, does new interval always exist? New interval.length is always equal to 2, so new interval always exists. Also want to check if intervals length right, if intervals.length, we can always just nullishly coalesce this, but that's sloppy. We'll just check, right, if intervals.length intervals.length is empty, then we're going to insert it should just be an array. So we want to only do this block if intervals.length is greater than 1. That's when the sorting will matter. But if we do const inserted, empty array, the empty array will give us no values. And so we could just add it to the 0th index, I guess. If insert that length equals 1, we could just return inserted. Inserted.length. It's actually clean. Maybe we could just leave this in. I see. No, because after we insert it, there'd be 2 elements. Take the min of both values. thing is simplified if we just do const sorted equals sorted sort. Oops. And then we'll just do sorted dot push new interval. I used B, which means what I did earlier was probably fine. Not A minus A, A0 minus B0. So that looks good. We ran into some sticky situations basically because I was trying to do the interval linear time or the insertion linear time, but yeah, that was just a lot. So that would be insert intervals.